Alright, so we're going to talk about AC power calculation. So this screenshot is from the textbook. So we want to calculate the average power, which is the real power, capital P. Okay, so the real power going to equals, based on this equation, is 1/2 of the current magnitude square R. Okay, and this R is a part of this impedance. So our first task is calculate the Z equivalent. Okay, so it's similar to this one. All right, so if you got this current, I square R is the P, and the R is the real part of the impedance. You have R and is have a JX, so reactance and resistance. Okay, so we just take the real part of that. And Im is the magnitude, which is if the Ig, the capital Ig, just equal to 4, 0 degrees. So here Im equals to a 4. Okay, Im equal to a 4 milliamp. Okay, sorry, the next part is calculate the Z equivalent. We first bring everything into the phasor domain. The capacitor becomes 1/j omega c. Okay, omega here is 5,000. So if you do the math, you will get a negative j 1250 omega, and the j omega L for the inductor, you will got a J500. Okay, these are the two impedance, and then the Z equivalent. So this equivalent circuit equals to this 500 plus this two branch in parallel. Okay, so this negative J1250 in parallel with another one is 1000 plus a J500. Okay, so these two impedance in parallel and plus 500, and in the end you got this one. Okay, so this is the equivalent in R plus JX form. So this is the R, that's the X, it doesn't matter. So the P just equals to 1/2 magnitude 0.04, because it's a milliamp square, multiply with 150, and that's it. So in the end you will find that one equal to a negative 12 milliwatt. Okay, all right, here is the next question. Is op-amp in the circuit showing the following is ideal. Calculate the average power, again real power P, delivered to the impedance resistance 1 kilo resistance here. Okay, so to calculate the power on this impedance, so we need to know the voltage here. So we call it output voltage here. So for the op-amp, there is a relationship between input and output voltage. Okay, so the voltage actually equals to a negative, sorry, it's not V, ZF, it's a forward impedance over the input impedance, multiply with the input voltage. In this case is VG. Okay, so here is the ZF forward, and here is the impedance, input impedance. Okay, so if we find ZF and ZI, then we can do this one. So ZF, okay, you can see that there are two impedance in parallel. So this one's 1/j omega c again. If you do the math, that is negative J 10,000, gonna in parallel with a 20K. Okay, then this one is actually equals to 4,000 minus J 8,000. Okay, the in here, you can see there's another capacitor which is 5 times larger because it's 1 over J omega C is on the bottom, so is a 5 times larger capacitance, so is 5 times smaller impedance, so that will be how much? 2,000. Okay, negative J 2,000. They are in series. This one easy, plus a 2,000 omega. So that's the in. So the F over the in equals to this one over this one. You have to use a scientific calculator. Then you got this one. Okay, and is actually equals to so the magnitude is the important part, right? Because we don't really care about the angle, but anyway, so this is 3 square plus 1 square and square root. It's actually square root of 10. Okay, square root of 10 with a this 100 something degree. Okay, so the output voltage V0 here is negative of that one. Okay, sorry, that angle is the negative angle. So because I don't really care about that, I just put a sign there. So this one I'm gonna put a negative sign for this ratio. So negative 3 plus J1 multiply with the input voltage, which is just 1 and with a 0 degree. And if you multiply that, you got 3.16, and that angle, that was that angle. Okay, and so the P equals to, we know voltage. So previously we got a I square R, right? Now we got a V square over R is still the same voltage. Sorry, it's still the same P. But here the V should be RMS value. Okay, what we got here is the magnitude. All right, so the magnitude is, so you know that Vm equals to it's Vm over root 2 equals to RMS. Okay, so we got this 1/2 V 0, the magnitude square, over R. How much is R? R is this one, right? 1,000. Okay, so that's 1/2 root 10 square over 1,000. Then we got the final value is 5 microwatt. 5 milliwatt. Okay, so yeah, that's the second question.